introduced OpenGeophysics and some of those ideas to the broader SIMPEG group, and that's what also prompted Dom to come join the conversation today, because he's doing a lot of potential fields and is very interested in a lot of the filters that you have in fatty endo, and potentially finding a way to collaborate on those. So that's one topic I think we can go over. And then I know Rowan and I have been chatting about namespaces and things like that over in the objective function side of things. So it might be kind of nice to just chat a little bit about scope and like what we want to do with that. Yeah, do you guys have other items for the list today?
So I haven't been a good student. I haven't really done my homework.
No worries.
I'm looking through this stuff now. So I see that there's an issue with scope, name, and dependency stuff. Yeah. So where you let me see. So the objective function repo has all of the fancy classes for doing the addition, subtraction, stuff for building objective functions, right?
Yeah. Yeah, that's okay. Sort of the first off the rank, and then some of the stuff in there, like it sort of quickly spins out of scope because it, like regularization are the hard ones, and like the objective function, and maybe that's fine actually for it to be a really small repository. Yeah, but the regularization stuff is where like sort of all of the instant or the subclasses would lie.
Okay, so you mentioned here that there's a dependency on discretize, right? And that would be for calculating the derivatives for the regularization. Is that correct?
Yeah, currently there isn't. I think that was sort of in there, like if we want to bring in the regularization functions that are gradient-based regularizations, or cross gradient or whatever, those pieces would require some sort of meshing functions.
Could we leave them? So instead of having the regularization take a mesh and then calculate the derivatives, could we have the derivatives as like the finite difference matrices as inputs for the regularization? So then you can get those from a discretized mesh, or if you get them from somewhere else, that would also be fine. You could reuse the same smoothness or total variation or whatever.
Cool. So like dependency inject your regularization, or sorry, your
exactly
stuff. Yeah.
Yeah. That's fair. Because some of the inversions that we do, this is one that a student in Rio is implementing and was done by Vanderlei, my friend there. Is that he has these, they're prisms, but with a polygonal cross section. So then he makes a stack of those, and he inverts for the position of the center and the radii of the what are they called, of the vertices. And he uses, I think, 4 different smoothness regularizations for that. So there's one to keep all the radii as close as possible to each other. There's one to keep the centers of the little prisms as close as possible to each other. There's another one that keeps each radii as close to their respective in depth. So it's the crazy regularization stuff. But the only thing that differs between all of them is the difference matrix. So everything else is the same. So if we can have the specialized classes that automate calculating the derivatives, but it would be good if they all subclassed from a general one that just, we do like a dependency injection where you just here's the gradient matrix, now do your stuff.
Yeah, no, I definitely was thinking that this library should not be dependent on discretize. And so, except it was sort of just a question I wanted to raise in this forum because of those regularization side of things. And so that sort of indicates to me that like a lot of the fancier or more specific regularizations would remain in a SIMPEG-like environment. And the base class basically is all we're moving at this stage.
Yeah, I think that sounds good, because we also have a lot of stuff like built in to go in and adjust your difference matrices based on if you have active cells and all of that kind of stuff. So there's just a few things tied up in that I think are very, like, it's useful from the user side because you just don't really have to think about it, but at the same time it would sort of tangle what's going on in the objective function library, I think.
Right. So okay. So you're also sorry. Go ahead.
I was going to talk about the other pseudo dependency question that I had, but you go ahead first.
What was I going to say? So okay, the same as for the optimization. So you also have things that interactively change the regularization, not just the regularization parameter, but the difference matrix itself.
Oh yeah.
Okay. So it's good to know, because I never used any of that. So all of these would probably need some form of callback, like some standardized way of changing them without the object itself needing to know what's going on. So that these could be, you could do like a SIMPEG specific change without the object needing to know about SIMPEG.
So I think in that case, just going in and changing the properties of the class, is that like, I feel like that sort of,
oh, right.
So the callback would need to happen on the inversion or on the optimization, more so on this side of things, because it's always just a function and you're just changing some of the inputs of that function.
Okay. Yeah, that's a lot easier actually. And so we could base all this off of the properties library, and then we can have some sort of validation as well.
Yeah.
Okay.
Yeah. And then the other piece that I was going into is there's some dependence on our side when I was pulling it out onto the mappings that we have, which are like one sort of example, although they're not inherited from the same thing, are the zero and identity maps, which like the identity map just does nothing to the thing before. But in SIMPEG, the idea of both mappings, so going from, say, like an exponential space or log space to an exponential space, no, a log conductivity space to conductivity space through an exponential map, and things like going from a 1D profile to a 3-dimensional Earth. Those are the types of things that we do quite often in SIMPEG, so that you can define your model separately than how you define your forward simulation discretization.
Right. Oh, okay. So these are sort of like variable changes for the parameters.
There's space changes for the model, so that you can define your model in a different space than how you simulate.
So same thing applies if we have a parametric model or something like that. You define your set of parameters, and then the mapping populates your mesh.
Yeah.
Okay, so these are not just like here's my parameter vector pre-multiplied by a matrix. You have your new mapped parameter vector and go on. So these also altered the mesh and stuff.
No. So one of the important things that if you're changing the space of your model, you need to keep track of the derivatives. And so that's why they're a separate piece, is that you have these chained maps that work together. So like some sort of surjection out to the entire space. So going from a vertical to a 3D volume is just a linear operator that you're applying there. And then an exponential is also a linear operator. And so taking the derivative of that is quite simple. And that can be plugged into your sensitivity calculation at the end. just through a chain rule. And so that's why you need to keep them separate, and you can't pre-multiply these things, because then your sort of model to your optimization problem changes.
Right. Okay.
So it's about keeping track of your space changes and the derivative to those changes, in sort of a very modular way.
Okay. And are these SIMPEG specific, or could they be generic?
I don't think so. I think they're like pretty base side of things. So you could also think about things like Archie's law as a mapping from one space, from a specific parameter space to another space. So you're going from saturation to conductivity, and you have some extra model parameters there that are changing the tortuosity factor and the whatever scaling factors that they put in there.
Okay.
So those sort of geoscience specific mappings are something that we've seen in the PyGimli space as well. So I think it is a shared conception.
And I do actually think it stands alone. Like, it's pretty isolated within SIMPEG. I mean, it propagates everywhere through, but I think that would be one that should be readily pulled out.
Would it make sense for it to be a part of the objective function package?
So there's in the sense that sometimes you want to do your regularization in a different, like, is there a good example of that? You might not want to. So I guess actually sometimes your model has multiple parameters in it. So maybe you're like going for saturation and conductivity, but you want a regularization only to work on the saturation part. Like that's one of your regularization functionals. And so you need some sort of mapping to isolate those variables in your model. And so that would be like, we call that a wires map, because you're just wiring up to one sort of set of parameters in there.
Okay.
So I could write that up a little bit more. It's like by default, it's an identity map, so it does nothing.
Yeah.
but it's basically like a pre-multiplier on the model before you get to your sort of regularization W matrix.
Okay.
And what's kind of neat about that too, that I think we can start to think about, is like a PDE is actually also the same idea as a mapping. You're just like mapping your model to data space. So it should generalize pretty nicely between regularization and data misfit. So. But I think that probably would be like a standalone package. That should be a standalone package.
Yeah, and again, it's actually quite small, and can be reused. And then I think I would say the identity and the zero mappings should actually be in that package, because we actually have an identity map right now and an identity object that work differently.
That's something to think about, Rowan, because we can sketch that out a little more, but I think that would require some thought, because it's really nice right now that the like zero and identity objects are quite lightweight. I would be hesitant to bog them down.
Yeah, that's a fair point.
Okay, I'm all for small tools.
Yeah, that sounds good.
Yeah, because every time you want to update something, and then you have this big code base. Okay, I'll do it later. And then
yeah, so I think the point there is it's not only small tools, but it's like a well-defined like namespace, and this is where Lindsay and I were going back and forth for a couple days on like what to name a thing, which I think is really important.
Yeah, that's whose quote is that? That one of the hardest problems in computing is naming things.
Yeah. It's totally
Yeah,
true.
that's very true. And related to that, I saw that you also have a PEP8 kind of issue.
Yeah,
that is rather long. Well, I hadn't realized it was so long. Okay.
Yeah, that's where we're having the naming debates.
Okay. Yeah, I agree. I mean, I don't really care about which standard it is, but the thing in favor of PEP8 is that there are tools that check it automatically, so you don't have to check it yourself. And there's this CI service called Stickler CI, and it'll leave comments on the pull request wherever there's a PEP8 clash. So it's really easy to follow. Like, it's go, and then it just leaves comments in every single line that you need to change something.
That's great. Yeah.
No,
Yes.
I think there's no debate whether we should do PEP8.
Mhm.
It's more that what do we name things when we're not naming things with the N
Yeah.
capital P.
Yeah. And I see that one of the suggestions here for NP would be N parameters. And I think it was, I was talking to this with John. Yeah, if you try to make the names as long as possible to avoid, because yeah, sometimes like NP. Well, what if I don't use P for parameter? What if I use X?
Yeah.
Or sometimes it's capital N and capital M, but in some places they're switched. So for me, N has always been data and M always parameters, but I've seen papers where it's the other way around. It's like,
Right.
oh, okay, yeah. It can get confusing if you're not the one who wrote and used the code, or even in different groups. Like I know that it's weird whenever I read a paper by your group there at UBC or Yago Lee's group. The notation is just very different from the things that the way we write things out in Rio. So it's always an exercise in translation, like automatic translation when you're reading the paper.
Yeah.
That's totally fair. No, I like the idea of defaulting to longer, more descriptive names.
Mhm.
And some things Lindsay was finding, especially on our world tour, was like when people are in a different country, small, those sorts of things don't translate. Like abbreviations don't translate if you're not a native English speaker either.
Yep.
So cool.
Have you tried using AutoPEP8?
I've used a bunch of those tools at work, like Flake, and there's some yet another Python formatter out of Google. There's also that Black thing, which happened last month, which looks pretty cool. So there's a bunch of things that we can automate and help do there.
Yeah.
I think.
Yeah, because the biggest trouble is like converting everything at once. When you turn on the PEP8 notification and it's huge, and
Yeah.
But I think when I did it, I just ran AutoPEP8, and then I started running the PEP8 check on Travis CI. So AutoPEP8, like the formatting is not the greatest. One thing I really don't like is that it puts spaces between the multiplication sign, and that just looks kind of weird. But I figured, okay, at some point someone's gonna change this code, and then they can just revert it back to no spaces. But it's just to get the status checks passing.
Yeah.
So that you can move forward.
With these small libraries as well, if we just enforce these standards from the beginning, then I don't think it'll be huge.
Mm-hmm.
Do we maybe want to start like a standards repo where we sketch out some of these things of just like how we're going to set up the repo, like what testing we're going to use for PEP8, all of those kinds of things? Just so that because we now already have 4 or 5 libraries going.
Yeah.
So it'd be nice if we're all using the same PEP8 tests and stuff like that.
Yeah. What did I write that in the Slack? About making a contributing repo.
Yeah.
So then that would that could host like a
standards.
Yeah, like a code of conduct, a standard contributing guide so when you're making a new repo, you could just pull in the standard document and then tweak it to whatever you want.
That sounds good.
And we could also have a short guide there about how would you go, like, say you have a library and you want to start a new library in the organization. Like, who do you contact? What are the rules for putting new stuff in? And
yeah, that sounds
things
good.
like that. Okay. I'm creating the repo now.
Okay, I'll let you do it.
Okay. Yeah, I can paste in some. So I recently did a lot of this for the GMT Python, and I was just going around and borrowing stuff from everyone. And the MetPy repo has some very good starter guides, and they use like 20 different CI things. So I just went and got a few of them. But yeah, their contributing guide is really good. They have some links. It's like short and simple, and Ryan, I think Ryan wrote it. It has some very welcoming language, like that imposter syndrome disclaimer thing. It's like, okay, that's a good thing to have. So
yeah, I saw that in Deep Look, and I think that is. I really like the imposter syndrome little write up, and I think that's really good.
Yeah. No, I love. Yeah, I saw the. I think that was in a PyCon talk, and then Ryan sort of tweaked it for the MetPy repo. So I just went ahead and copied that.
Nice.
Excellent.
One quick comment. So I've started playing around. I'm sure you guys saw that, like, test IPyNB. If you end up playing around with it and have ideas or suggestions on how to improve stuff, this was like my very first time fooling around with NB convert. So very open to ideas around this, but I thought, yeah, it's nice to actually have something that'll just run your notebooks and make sure that they run. So that's sort of the idea there.
Is that so you made it into a package itself, right? You can pip install it.
Yeah.
Okay. Yeah, I think I'll probably pull that into the as a dependency on the paper template that I was making, because there I just have I just call it from the command line.
Yeah.
But it just looks very ugly. So I gotta hide it in a script somewhere. Do you think did you make like is it callable from the command line or just as a library?
Right now it's just callable as a library, but we should, there's no reason not to make it callable from the command line.
Yeah. And another thing, when you run the notebook, do you? Because I think when you call run, it creates a backup copy, right, of the notebook.
I don't call run. I'm calling the execute preprocessor.
Yeah, exactly.
For NB convert, and so I first go in, clear all the outputs, and then go ahead and run the notebook. I don't think that this version creates a. It doesn't create a backup.
Like a temp file or something?
Yeah, no, I don't think so.
Okay. Because the way I was the reason I was using this is so that I could run the notebooks from a makefile.
Okay.
So I could. It would be kind of like having the best of both worlds between a notebook and a script.
Yeah.
So I can edit things interactively, but then once I'm done, instead of restart and run all, I could just save it and then do a make. And then it would run the notebook. but I wanted it to actually update change the notebook file itself.
Okay. I think
Um,
we can play around with this. I think that this actually probably this would update the notebook because it is actually going in and running the exact notebook.
Mm-hmm.
So it will run it, like it clears everything and runs it clean.
Okay.
So.
Okay. Yeah, I'll take a closer look at the code. I haven't seen what you're doing under the hood.
Fair enough.
Okay.
Dom, is there stuff you want to bring up with respect to the filters? Or like how you see going forward with that?
Well, okay, so this came back because starting talking to Diane, right, about working closer to the geologist. And this is going to be the first, definitely the first step for them is going to be using the potential field filters.
Mm-hmm.
So I was double checking what you did. I kind of like benchmark it against like something simple. It looks great. I think kind of like the bottleneck right now is the gridding, how the scatters are gridded. You know, like GeoSci are doing something fancier, like minimum curvature, which happens to give slightly better results, less artifacts when you're in the Fourier domain.
Yeah.
What's the state of your work on the filters?
So I haven't messed with the filters in a while, but I think that's what people use the most. That I don't know why, but Euler the convolution is just so popular. I think that what people probably use the most out of Fatiando are the filters and the Euler the convolution. But let me do a quick check here. So most of them assume you have gridded data already, so they're not doing any of the gridding.
Yeah, that's right.
And they're not doing anything too fancy with regard to the FFT, but we do apply some padding. So Andy Cass did a lot of work on that. Do you guys know him? He was Yago Lee's student.
Yeah, I met Andy, yeah.
So he wrote all of the padding stuff, and we have like some. I'm not sure that it's actually being used everywhere consistently. I think I went in and changed that, but I don't remember. I'm trying to look through the code here and see. Right, so the only fancy thing we do is actually apply the padding to the grid.
You taper, is that the strategy?
Yeah, I think the default one was to use a cosine taper. So instead of just propagating, I think it applies some sort of taper. Yeah. And then so we apply the taper, do the FFT, do all the calculations that we need, and then when we convert back, we get rid of the excess. And for the derivatives, what I found is that if you're dealing with a dense enough grid, even with all the tapers, the FFT grid, the FFT derivative is just no good. Doing just a simple finite difference, a forward finite difference or a central finite difference in the grid gives you better results than doing the FFT, especially if your data doesn't taper to 0. So if there's any sort of trend in your data, doing the derivatives with the FFT just gives you a whole bunch of artifacts. Yeah. Yeah, so the default in the filters right now is if you're doing derivatives, they default to finite difference.
Oh, okay, I see. Oh, that's the same result.
Except for the z derivative. The z derivative is FFT, which is fine.
And like upward continuation has to be done in the FFT too, right?
Yeah, yeah. We used to have a space domain upward continuation, but I think I removed that. No, the code is still here, but it's not being used because it's a pretty stable thing. It's just the space domain formulation was kind of interesting. So instead of instead of doing the convolution through FFT, I'm integrating I think it's a trapezoid rule to integrate the convolution integral.
Okay.
And that works out pretty nicely, actually. It's a pretty stable result, but it's slower than FFT if you have a large data set. So it's not really worth it. But yeah, Z derivative and upper continuation are very stable, and you don't get any sort of artifacts. So that's why those are the way they are. And the other thing we had was, so anything that relies on derivatives, like total gradient amplitude, that also defaults to finite difference for the horizontal derivatives. And the tilt calculation, I think, also defaults also to finite difference. The thing that we have that is different, and I haven't seen this in many other softwares, that our reduction to the pole takes as input also the source magnetization direction. So instead of implicitly assuming it's only induced magnetization, we kind of we force you to make that assumption explicit. So we take a geomagnetic field incandec and a source incandec as well, which the last time I checked, I think GeoSoft doesn't even allow this. So if you know the magnetization direction, you can run the reduction to the pole with the proper direction.
Yeah, that'd be optimal for sure. Yeah.
Yeah, and if you have an approximately, and by approximately spherical, I mean if you upward continue enough, you can, anything is approximately spherical except for a dike, maybe. But there is one algorithm here that was someone's master's thesis where we estimate the magnetization direction based on assuming like we assume it's a sphere, and then we invert for the magnetization direction, and that works pretty well if you get the center of the sphere from Euler deconvolution, and if you upward continue the data so that it's approximately spherical, that works very well. It's super robust. And
for a compact object, for
a compact object, yeah. Even if it's kind of flattened or everything, we tested it with flattened objects, or perfect sphere works perfectly, but even if you have a flattened object, that works perfectly if you upward continue a little bit. So that's an interesting thing. It's a good way to test as well if you do have any sort of remnant magnetization or any demagnetizing effects.
So you think it is worth it to bring it to the surface, the filters, or we can just call the library whenever we need it? Because it seems like it is used, like people use it a lot. And
yeah.
Like it's not necessarily easy to find through Fatiando. If you just look for filters online, it doesn't really come up. So I don't know. Can we expose it better? That's my own. And can you contribute only on that level rather than going to the stack? I'm just throwing it out there.
Yeah, I mean, for sure, because these filters, they don't depend on anything else, or there's the only thing that they depend on is a function to calculate a unit vector from a set of angles. That's the only dependency they have on the rest of the library, and it doesn't really. These could certainly be standalone thing. The derivatives, particularly the horizontal derivatives, I was going to include in the standalone gridding package. but that could come out later, and we can always strip it out afterward.
Usually to grid?
Sorry?
What are you usually using for gridding? You're just doing a linear, or like you using the SciPy?
Yeah, I was just using the SciPy stuff.
Yeah.
But I've been working on some different on Green's functions based gridding.
Yeah.
So I'm gonna try to. I'm gonna have to strip that out into its own thing anyway, because that's part of the work I'm doing here. So I thought of including the horizontal derivatives because those don't depend on any assumption of being a harmonic field or a harmonic function.
Yeah.
The z derivative wouldn't work if you don't have a harmonic function, but for the rest, it's just for any kind of grid, or if you're doing equivalent layer stuff or any kind of Green's functions based processing, you can calculate the horizontal derivatives through finite difference, even if you don't have a gridded. Even if you have like random point scatters, you can still do it, because you can just shift the points back and forth a little bit, and you could do arbitrary precision finite difference.
Oh yeah.
Because it's all just forward calculations. Right?
I see. Okay, that's good. So yeah, I don't know what to say more than that.
So would you prefer if the filters are their own thing, or because I'm also stripping out the entire gravity and magnetic package and sort of going through and cleaning a lot of the stuff, because a lot of the communication issues were just immaturity on my part when I started all of this. Didn't really know what I was doing.
Who knows?
Exactly. So yeah, it's not very well marketed, and the documentation is very convoluted. It's like you gotta go down this rabbit hole in order to find the functions. So what I had in mind for all of these packages that are going to be stripped out is having a linear namespace, kind of like in NumPy, their functions are scattered around in different files, but they import everything into the NumPy namespace. So that's why you can do like numpy.min, and if you do numpy dot, there's like a ton of functions, right? And those are scattered around in different files, but it's easier to find in the documentation, because you just go to the NumPy API and there's this huge list of functions that you can search.
Yeah.
Right. So that was kind of the idea of one of the things that I wanted to do with all this refactoring is just, okay, let's have a clean namespace, and no matter how you organize the files, the way you use it is always through this single namespace.
Keep on the top, yeah. Sounds good. Yeah, that's great. And the gridding also, man. If you do some progress on better gridding, that's super useful. That'll be used right away.
Yeah, all this Green's functions gridding is on. So that was a big learning curve for me. So this is what they're doing in GMT. It's all based on this. And the main GMT gridding function is a finite difference solution of this this spline differential equation. So it's like they're getting a elastic sheet and applying tension, and then deforming it with the data points.
Yes. Yeah. Which
and then
really. Yeah.
Yeah. And they have this fancy adaptively refined finite difference solution thing. That's the GMT surface command. But they also have sort of the same things, but doing with a Green's functions approach, which is like the equivalent layer thing in potential fields.
Okay.
But instead of using like a gravitational attraction of a point source, they're doing it's like elastic deformation of a point force applying vertically on a elastic sheet or something. And there are solutions for that, even for defining things in spherical geometry. So you can do gridding in geodetic coordinates, for example, instead of just doing everything in Cartesian.
Right.
I gotta run.
Okay.
But
One more quick thing before you run, just to think about, is I think it would be good to get the PyGimli folks involved, especially in some of these earlier conversations, so they can help shape things. I don't know how best to do that, but maybe what we could even do is just draft up an email and say, like, hey, we've started a thing. Do you guys want to get involved? That could be a good way forward.
I mean, how small do you want to keep these conversations?
I don't think we want to go too big yet. Like, I feel like we need to get some of the stuff around like contributing and what the scope of this is hashed out a bit before we go and invite too many people.
Yeah, it needs a critical mass before we bring on too many folks for decision making.
Yeah.
Yeah, but we should definitely include the PyGimli folks. At least one or two of them will surely be interested in this.
Yeah.
Okay. Well, we can draft something up this week and then maybe get them involved in the next call or something like that. Cool.
Yeah.
Awesome. Very cool.
All right. Well, thanks, guys. Have a good afternoon.
Thanks. Yeah.
Cool.
That was a nice chat. And Dom, we can. I'll draft up what I'm thinking about for the graphene magnetic thing, and we can talk. See if it would be worth just having these in a standalone thing.
Yeah.
The filters.
Or again, we can we can start just using more the library once more like close to the surface.
Yeah. Okay.
Bye-bye.
Yeah. See you.
See you guys.
Okay. Bye-bye.
Bye.